Let's talk about Newton's third law of motion now. Newton's third law of motion says, for every action, there's an equal and opposite reaction. This means that every single action that is occurring, there is another action that is also occurring in the opposite direction. So when we say that there's an equal and opposite reaction, we basically mean that there are two forces taking place that are both equal to each other. One is pointed in one direction and the other is pointed in the opposite direction. So let's say this is our action. We have a force pointed to the right. Well, we would have another force pointed back at it to the left, being the reaction. We can see that these two forces are the same size because their arrows are the same size, meaning that they have equal force. We can also see that they're pointed in opposite directions. Forces are going to occur in pairs. And like we said before, we would have an action-reaction pair. In this case, our red arrow is our reaction and our green arrow is our action. Let's take a look at an example here, where to the right we have a picture of a bat. The action force is the ball pushing the bat to the right. The reaction force, though, is the bat pushing the ball to the left. Equal forces, opposite direction. One is to the right and the other is to the left. Let's take a look at a few more examples here. And we want to figure out what are the action and reaction pairs in the picture below. On the left side, we have a baseball player with a mitt and a ball. I see that a ball is pushing this mitt to the left. So my action force is going to be ball pushes mitt to the left. My reaction force is just the opposite. The mitt is pushing the ball to the right. Look at our example to the right now. Again, we have a ball pushing a pin to the right. And then we have the pin pushing back on the ball to the left. For the baseball and the mitt example, the forces are going to be equal. So the force of the baseball is equal to the force of the mitt. And for our bowling ball, the force of the bowling ball is going to be equal to the force of the pin. Again, Newton's third law says equal forces, opposite direction. It doesn't matter what the two examples are, as long as those two objects are in contact with each other, they're both exerting equal forces onto each other. The only difference is that those forces are in opposite directions. Summarizing what we just talked about, inertia is telling us that objects will continue to do whatever it is they're doing. So objects at rest will stay at rest, and objects in motion will stay in motion. Newton's third law is just telling us that every action has an equal and opposite reaction. Basically, that's just telling us that forces occur in pairs. Those forces that occur in pairs have the same force value. The only thing that's different is the direction that that force is pointing in, and they're pointed in opposite directions. So again, if this is one of my forces, this is my action force, and let's say that this action force is 50 newtons, I would have a reaction force pointed in the opposite direction with the same magnitude of force. No matter what the example is, we need to remember that those forces are always equal and opposite. So if I gave you an example saying that you were driving your car down the street and a bug hit your windshield, who felt a greater force, the bug or the windshield? A lot of people get this question wrong and they say, well, clearly the windshield. Look at what happened to the fly. That's not right. The fly and the windshield are feeling the exact same force. The reason they feel the same force? Newton's third law. The reason the bug goes splat? Well, you'll have to wait for next time when we talk about Newton's second law.